So this time we are talking about finding related rate. Okay, so on this textbook here, so we have seen how the chain rule can be used to find dy over dx implicitly, right? So another important use of the chain rule is to find rate of change of two or more related variables that are changing weight respected time basically. Okay, so that's the key point here. So like other normal functional case, we just do dy over dx. So this time we are doing dy over dt over dx over dt. Okay, therefore you have to keep all different variable change value, even x value or y value, everything here. Okay, then look at this example here. So what I've given v equal to pi over 3 r squared times h here. Okay, now we are to find out the derivative, okay, implicitly with respect to t to obtain the related rate equation. Then now, so we are treating that all like a single variable, but we are derivative by dt. Okay, therefore, this means just y, so we can make 1 times dv over dt. Make sense? Oops, so I'm gonna just write a little bit more clear. So 1 times dv over dt, so equal to now, this pi over 3, that will be constant value, so still pi over 3 times. Now that you're using the product over here, so a equal to r squared, and then b equal to h, and then a prime 2r dr over dt, b prime 1 dh over dt. So you multiply closely, then becomes r squared dh over dt plus 2hr dr over dt. Okay, that's why you are seeing all this row here basically. Okay, so like this. Now if you make the rate of change, then we always make this kind of rate based on this t value here. Okay, then let's look at one example. So suppose x and y are both differentiable functions of t and are related by the equation y equal to x squared plus 3. Okay, so this kind of question, so they always give us some known value here like this, and we are going to find out some other the rate of change value here. Okay, so now I'm gonna copy this one to my whiteboard, and we keep on working on this problem. Okay, so now we derivative each variable based on dt. Okay, therefore this become dy over dt equal to 2x dx over dt, and constant nominal it becomes 0, so that's it here. So that's the derivative based on dt so far. Okay, now the question asks, we are looking for dy over dt based on all the known value here. So now you are plugging x equal 1 into here, and then dx over dt value 2 into here basically. Okay, if you do so, then dy over dt equal to 2 times 1 times 2 here. So the rate of change y value dy over dt becomes 4 basically. Okay, so let's look at another example. So pebble is dropped into a compound, causing ripples in the form of concentric circles here. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second when the radius is 4 feet. And what rate is the total area of the disturbed water change? Okay, so this means basically you threw something in the compound, so then basically it kind of makes this kind of water waves. I mean something like this anyway. Okay, so we're gonna find out because at the beginning this really small circle, but it's getting bigger and bigger, right? So we need to find out the rate of change for area. Okay, so it is circle, so you need to know what the circle formula is. So what's the area formula for a circle? Yes, that becomes pi r squared, right? This time even though it is given as the diameter, you still define as radius because area is always defined by r. Okay. Then now, so from here, let's collect all known fact. So I can find out radius r increasing a constant rate of 1 foot per second, which means we can make dr over dt equal to 1 foot per second, and then given radius r equal to 4. Okay, using these two information, we can find the rate is the total area A, which means you are looking for dA over dt basically. Okay, so let's start derivative this formula here. So then this becomes, so dA over dt, why I just got dA over dt here, right? Equal to pi is constant value, so pi times 2r times dr over dt. Okay, now do we need to do anything else? Okay, no. So now we are inputting all known fact. So this into here, this into here basically. Okay, if you do it, then dA over dt becomes 2 times 1 times pi times, no, sorry, 2 times 4 times pi times 1 here. Okay, therefore this become 8 pi. So answer dA over dt becomes 8 pi square p per second. That will be the answer for this problem. Okay.